right, classwork on the chalkboard. So we got just a few equations to solve here. We'll do a couple more once we're done with these 4, and then continue working with what we were working on yesterday. Want to make sure we don't forget how to do these other equations as we work through literal equations. That's the projector. It's warming up. used All right, go ahead and put your pencils down. Even if you're not finished yet, take a look at these first few problems on the chalkboard. Absolute value equation, remember the key is to isolate the absolute value, so subtract the 3, divide the 2 to get the 6, then set equal to both positive and negative 6. And you still have to get two answers, 13 and 1. How many have those two answers for this first problem? Questions on this first one? Now, what if this had ended up with like a 6x right here? Well, then I would set that equal to positive and negative 6x. And of course, the work would have been different, right, if there had been an x there. But what's the key thing to remember if there's an x outside and an x inside? Absolute value, anyone? Check your answers, because very possibly one of your two answers is extraneous. Good, Brandon, extraneous. We also had an absolute value inequality. And again, the same initial step, right? Subtract or add the 4, divide the 6 to get the absolute value isolated. And from there, remember, you're either going to fall outside the absolute value, or outside the 2 points, positive and negative, because of the greater than, or if this had been a less than, it would have fallen inside, and you solve like you normally would, and your answer ends up being everything smaller than negative 1, everything bigger than 2. Then we'd write it this way, because we have the or equal to, we'll use the bracket. How many have these answers? Really, this answer is just two parts to it. Have this answer on the second one. Anyone go inside instead of outside? All right, questions, comments on this second problem? Looking at the third one, pretty straightforward LCD, right? 5, 2, 10, so multiplying everything by a 10, cancel the 10 and 5 to get 2, distribute 4x to negative 14, cancel the 10 and 2 to get 5, but it is a negative 5. So negative 5x, positive 20, and of course get the x over there. Combine, end up with a negative x and a positive 6, and move the negative x over as a positive x to get 2x equals 6, so x is 3. How many had 3 on that third one? Okay, any questions there? Genesis, you just came in because you were taking care of some other things. You didn't have opportunity to do these. Are there any questions on them? Feel like you're pretty confident on these? All right, let's take a look at this last one on the board then. I see a polynomial denominator, and the key to polynomial denominators, class, is either factor or group. In this case, we're going to factor out a 3 times the quantity x plus 2. All right, so when we get our LCD for this problem, what is that least common denominator, Michael?
21x plus 2.
Good, the 7, the 3, the 21 are all taken care of with the 21, and then the x plus 2 needs to be included as well. So when I multiply by 21x plus 2, of course the 7 is going to cancel, but I'm going to be left with what still, Kendall?
3. And then the x plus 2.
3 and the x plus 2, and that's got to be multiplied here. You could FOIL, then distribute. I feel like it may be easier to distribute first, then FOIL. It's really up to Audrey.
Distribute to get 3x plus 6.
Okay, so you were thinking kind of the way I was thinking. And when we FOIL, then here we get
6x squared negative x.
Careful. This is negative 9, but I think you were thinking 8. 6 times 2 gives 12. So we should have 12x negative 9x
3.
x.
Negative 8.
There we go. All right. And then here, the 3 and x plus 2 are going to both cancel. But what's still going to be left, Maddie? A 7, which that's just a straightforward distribution. And then obviously in the last fraction, the 21 is going to cancel away with the 21, but we still have, Brandon, the
Times x plus 2.
right, we've got this x plus 2 that still needs to be multiplied by a negative x to get.
Negative x squared negative 2x.
There we go. From here, what are we going to have to do, Abby?
You can combine like terms.
Okay.
The 7x squared and x squared.
To get.
To a 6x squared.
And thoughts on the 6x squared?
You can cancel with the other one.
Yeah, so together, these combined cancel the 6x squared away. That's awfully nice.
And you move the negative 2x over as a positive 2x. And simultaneously...
Ooh, good word. All right.
The negative 8 over as a positive 2.
Okay, and we get...
You get 5x And negative 45.
And so our answer would just be
Negative 9.
negative 9. How many finished the problem and got negative 9? Okay, only a couple of you. How many were working on the problem? You were on the right track, at least just hadn't finished yet. All right, questions on this? Any questions on this? All right, well, we've been working on more recently. Again, this is stuff that we should have done pretty well at this point. We've been working on equations with extra letters in them, more than just, for instance, the x that we saw here. What do we call those equations? Genesis? Literal equations. And we said that a common example of a literal equation is something we use a lot in science, or geometry even. Anyone?
Formula.
Formulas, right? Formulas are a good example of literal equations. For instance, you might have a literal equation or a formula like d is equal to 2/3 m squared x. And in this formula, what do we call the d right here, Maddie? The dependent variable, because it depends on what we plug in class for both m and x, right? Depending on what we plug in, it's going to determine the value of d. M and x, on the other hand, are referred to as independent variables. Good, Brandon. Then what about the 2/3 right here, Abby?
Constant.
Call it constant. Its value's never going to change. It always means 2/3. Actually, see, I want you to get the x by itself, and then I've got another literal equation, though this one not so much of a formula-looking one. And again, solve for the x in both of these. Michael's got him. Brandon's got him. There you go, guys. Clean sweep. Yeah, Gavin and Brecken are done too. Oh, now Abby's done. Audrey's done. I almost said Aubrey. That's not right. Audrey's done. Maddie's done. Kendall's done. What do we need to do on this first one here? Genesis, because I see something I hate. And it's not Brandon this time. We love Brandon. Michael, right? You see, well, I see M, right? But normally I don't hate M. Only when it's, never mind. All right, so fractions, right? I could easily get rid of the fraction if I do what? Multiply everything by the LCD. Now, everything, there's only two things, right? This is a thing, that's a thing. Let's multiply both things by 3. And when I do, it'll give me what?
3 equals 2 m squared x.
There we go. And now I still want to get the x by itself, but at least the fraction's gone. I actually recommend this initial step here. What then could I do to get the x by itself? Good, divide away both 2 and m squared, and what we do to one side. So my answer is, there we go. How many have the same answer Genesis had on this first one? Questions? It might have looked different if instead you multiplied by the reciprocal. I don't like the look as well, but if you multiplied by the reciprocal, you'd get a 3d over 2, and then you could separately divide away the m squared. That would also be a correct answer. Did anyone have that answer? Again, it doesn't look as good, so that's why I'd rather just knock the fraction out in one step, then take care of the rest, but it's not wrong. It's not a wrong answer either. Questions? All right, coming over here, and let's go to Kendall. What do I need to do here to get the x by itself?
You add CD to both sides.
Yeah, or just bring it over as a positive CD would work as well, but yeah, add to both sides to get
A plus CD equals BX.
good. Don't try to combine the A with the CD and sound like an ACD. No, there's two separate terms. A plus CD equals BX, and then simply the B from
both sides.
both sides. Now you could say every term. You could do it that way as well, but it's easier just to divide away from the full side. And there's our answer. It would be the same thing, by the way, if the B were below the A and below the CD separately, but I'm too lazy. How many got this answer on the second one? Any questions on literal equations? We're going to look at some slightly more challenging literal equations here in just a moment, but for now, let's go ahead and take a look at some word problems. And most of the word problems we're going to do today, very quick, very easy, simply algebraic representation because they're one unknown word problem. So at your seats, take a moment, write an equation, and solve. Patty's got it, Michael's got it, Brandon's got it, Audrey's got it, lots of people got it. What equation did you write? I think Maddie was first. Maddie, what was your equation? Good, 16x minus 12 equals 84. It might be tempting to switch this around and say 12 minus 16x, but write this in your notes if you didn't get it earlier in the year. From comes first. In subtraction, from comes first. You may notice it says if 12 is subtracted from 16 times a number. Well, that means the 16 times a number better come first, and from that, we take away or subtract away the 12. Does that make sense? So watch that word from in subtraction, and then from here, pretty straightforward, 92 steps. First, you add 12 to get 96, and then also we mentally know we need to divide away the 16, so we do that too. Maybe on our calculator, maybe not. We get 6 for our answer. How many had 6 for your answer? Questions on this first one? All right, here's another one for you. Read it carefully. Equation, then solve. Again, when there's only one unknown, just representing it. There's only one unknown. What's the number? Singular. I don't know who was first. You was first? Good job, Michael. Abby's shaking her head like, I don't want that. I don't demand a recount. Can we get instant replay on this? It's like pencil going down. Yes, fraction of an instant. His pencil did hit first. Michael. All right. Michael, what's your equation? If 5 times the number is taken from 7 times the number, the result is 18.
I did 2x equals 18.
Okay, you condensed a little. What's the initial equation, though?
7x minus 5x equals 18.
Right, from 7 times the number, so start with the 7x, take or subtract 5 times the number. The result is or equals 18. How many had this equation? Though, of course, in our heads, we know that's going to be 2x equals 18, and therefore we know the number is? 9. How many had 9 as your number? Good. Take a look at this one. Same thing. Working very quickly, very efficiently on problems like this. And gearing for speed and accuracy here. This is an annoying one, isn't it?
I finished first.
You did. I saw this one. Sorry, Abby, he did get you. I'm going to let you answer it anyway here in a minute. There's no sibling rivalry here. I had sibling rivalry with my sister. She was a year older than me. Well, she was 2 years older, but she was 1 grade ahead of me because she started late and I started early. And she had a 4.0, straight A's. I was like, I'm smarter than she is. I know I'm smarter than she is. But if I got a B in something, like penmanship, okay, my penmanship wasn't as good as hers. I eventually made A's, but like it took forever. But like once we got to high school, right, no penmanship grades, I was all about that. Like I know I'm smarter than she is, so I can't get a B. Like I'm lazy, but I can't get a B because if I get a B, then it looks like she's smarter than me. And so she never got a B, so I couldn't get a B either. What was your equation initially?
4x plus 3x minus 6x equals 7.
And we combine all the x's, you just get
1x.
x. So
X equals 7.
x equals 7. 7's our answer. How many got that answer? All right, good. So Melissa, in case you're watching. Down in Papua New Guinea on the other side of the world. of the story is, Michael, if you don't like your sister, just find a way to get her on the other side of the world. You'll never have to see her again. I'm kidding, Melissa, I love you. We video chat when we can. Like if I'm up late at night and she's up early in the morning and it happens to coincide. I don't know. I like a tie there.
I'll let her have it.
He's so gracious. You can have it. Well, I don't want it now.
I was only late because I covered it down wrong.
Oh, excuse me. All right. So Audrey, what's our equation?
154 minus 5x equals 16 plus x.
All right. If 5 times a certain number is subtracted from 154, the result is 16 plus the number. A little bit more involved than the last few. How many have the equation correct? Questions on the equation? We had some people with it not correct. What did we have? Give me some feedback.
I switched the 5x. I had 144.
So you have 5x minus the 154, right? But you see the from 154. Again, that's okay that we mess it up because it gives us a chance to work on it. Okay, just copy the 154 down wrong. Any other questions, comments, feedback? All right, from here, Audrey, what do we need to do to solve? Sorry.
You add the 5x on the side.
Audrey would be like, it's not fair. I've been a student for years. She's a new student. I don't know. I'm sorry. I have her earlier in the day, just like I call him Dylan sometimes. Or sometimes I call Dylan Brandon. So anyway. All right, so that gives us a 6x. And of course, we also need to move the
16
to get. Surely you already had it.
Yeah.
On the calculator. You did all this in your head. When she did in her head earlier, she got,
138.
and then she divided that by 6 and got
23.
23. Is correct. How many have 23 as the number? Okay, questions on this one. Get a little bit more involved. I got to read it a little bit more carefully. All right, another one for you. Michael's like, done! 2, the answer is 2. I'm going to laugh if it is 2. I don't know what the answer is. I don't think it's 2.
I got it.
That look she gives you, though.
I said I got it before she said it. Pencil down.
Yeah, instant replay shows we go back and watch the video. We can hear the clack and the I got it, and we hear I got it just before clack. I'm just saying.
But I finished before I put my pencil down.
I said I got it after I finished.
And Kendall's up here like, I beat all of y'all anyway. All right, Kendall, what's the equation?
12x minus 4 equals 10x plus 14.
Good. If 12 times a certain number is decreased by 4, not taken from 4, but decreased by 4. So we do want the 12x minus 4. The result is or equals 14 more than, generally means flip the order, though addition's commutative. But I like that she put the 10x before the plus 14, though it would not be wrong to have 14 plus 10x. How many have this equation? All right, questions on how we should have gotten that. Does it make sense now? All right, to solve, what did you have to do, Kendall?
You subtract 10x.
To get 2x, and you
add 4.
to get,
15.
so your answer is
9.
9 is your number. How many had 9 for the number? Questions on this one? One more. Ooh, this will make you think. Three times a certain number decreased by 13 exceeds the number by 9.
I finished.
Find the number. He's like, I found something that annoys her. Well, another something. I'm sure you found lots of things. Oh yeah, that's what brothers do. Right, Audrey? Brothers annoying. Little brothers are the worst. Is that what it is? But he's a big brother, so.
Little brothers are worse.
Is that true, Abby? Little brothers are worse than big brothers? She's like, not at the moment. The first part of this is going to be pretty straightforward. Genesis, it says 3 times a certain number decreased by 13. I should simply write, She's getting all teary-eyed. This is just such an emotional moment for her. Hey, don't laugh. We need to, support her in this emotional time. Support me by calling out Brandon.
No.
Okay, I couldn't see. 3 times 3x
Right?
minus 13.
Right. So we have 3 times a certain number decreased by 13. And then we see our verb, which normally, class, our verb is our equal sign, right? And it is, but it's more than an equal sign because it's also telling us something else. What does it mean for something to exceed something by 9? For instance, if I said that Abby got a 87 on a quiz and that Michael's score exceeded hers by 9, what would that mean, class?
It's supposed to be 90.
He scored 9 bigger, right? 96, right? 9. And she's like, that's never happened. But 9 bigger, right? So not only is it our equal sign, it also tells us 9 bigger than something. In this case, 9 bigger than what, class?
X.
The number, x. So over here we should have x
Oh,
plus 9, right? Another way to think of it is this does not equal the number because it exceeds it by 9. So we have to add a 9 to make it equal out. As another way, I guess you could think of it. Did anyone have this equation? Several of you did. Wow, those who didn't, this is something a little bit more involved than we've seen before. Does it make sense now, though? All right, and to solve, Brandon, what would we need to do?
Minus the x.
Okay.
Plus 13.
And so apparently our number is 11. Our answer. How many had? I guess those who had the equation presumably had the 11. All right, questions on this? All right. Let me drag this back over here. All right, I've got a handout for you. And we're going to continue working on literal equations. Of course, we kind of moved off of formulas. Okay, not that we're not still going to see some every now and then. We've got some other equations for you here on this handout. And of course, if you're watching on YouTube, get the get the document from the description of the video. You'll see it there.
Can we write on it?
Sure. There's not a lot of room to work anyway, though, frankly. So you're probably gonna have to copy it over in your notes anyway. I want you to look at number 13. Number 13. And of course, we know it's a literal equation, class, because we see lots of letters, right? Normally we would solve for x. In fact, that's what it says at the top. Solve for x. It says check each result. We don't do that here. We're too lazy. But we see other letters, right? We see A, M, B, not necessarily in that order. And so we also see something I hate. Class, fractions. That's okay, because we're going to get rid of the fractions anyway. Really quick, what are we going to do to get rid of these fractions here, Genesis? All right, multiply everything by LC. So every single thing gets multiplied by what, Genesis? MB, or BM, if we want to go alphabetically here. Bam. And so what do we get when we multiply everything by BM? Continue. Oh, careful. These are over ones right now. It's tempting though, right? So I'm actually glad you said it because it gave me a chance to caution. Yeah, don't cancel those m's. Put it over 1. We're going to multiply instead.
A M plus B.
Well, we're multiplying.
A B.
There we go. Okay, then we multiply the next one. Notice the negative though. Don't lose sight of that.
Negative B squared M.
And then in the next room, we are going to cancel the to be left with just the x. And then after the equal sign,
Cancel these. And
there we go. And again, we're solving for x, and we said yesterday that when you solve for x, if there happen to be multiple x's, like there are here, here's an x, there's an x. Well, we used to say get rid of the little one. We don't know which one's the little one. So I said, instead of trying to get rid of the little one necessarily, I said, let's get all the x's together, class, on one side, and anything that's not an x, let's move to the other side. Well, here are your two x's, and here are your two non-x's. So which x would be the smart one to move, class? The bx. Because these are already, the two non-x's are already together, so if I just move the bx over, class, as a negative bx. I've got my x's on one side, my non-x's on the other. And I said, after you separate it out, after you get x's on one side, non-x's on the other, the next key step, class, is to factor. What do we need to do to factor here, Brandon?
Take out the x.
Good. On the x side, you'll almost undoubtedly factor out an x. There may be more factoring, but at least an x comes out to leave us with.
A minus b.
But what about on the other side? I said on the other side, let's see if we can factor as well.
You can take out a b and an m.
Good. I can take out a b and an m, and that'll leave us with am minus b. And then to finish solving for the x, class, simply divide away the am minus b. Now, I will throw this thought out there. For all practical purposes, we could just cancel them. However, we would have to specify that am can't equal b, or that b cannot equal am when we write our answer, that x equals b. Questions on this? Seem fairly straightforward? As long as we remember the basic steps, right? Clear fractions if there are some, separate the x's and the non-x's, and then factor. Take a look at number 9 with me as well, if you would, please. We have an x over b minus x plus 2b over a is equal to 5. Let's go and put that 5 over, wait, I'm somehow mixing my problems. We're on number 9. There is no 5. 5 is a number 11. A over b minus 3. Let's put the 3 over 1. Yeah, just make sure we know it's not a denominator. Always good to put things over 1. And Michael, what do we do?
You're solving for x, so you
Right.
need to get x by itself.
Ultimately, yes, but in the meantime,
Multiply by the common denominator.
yeah, let's get rid of those fractions. I hate fractions. All right, so
AB.
AB, not Abby, but AB. All right, and what getteth we when we multiplieth everything by AB?
Ax minus bx minus 2b squared.
Good job. That's a negative b being distributed, so negative 2b squared. Fantastic. Keep going.
Equals a squared minus 3ab.
All right, and so now at least the fractions are gone, and you said to solve for the x, well, you didn't say this yet, but you're about to solve for the x, we need to get x by itself. But the first step in getting x by itself is to get the x's by themselves on one side, non-x's on the other. What would we have to do to accomplish that?
Factor.
Not yet.
Get the b out of there.
Which one?
The 2b squared.
Right, here we go. This is a misfit, right? It doesn't fit in. There's x's over here. It's like the one guy trying to sit on the girl's side, and the youth pastor be like, no, get back on the guy's side over there. And he's like, well, she's cute. She's looking at him with disgust anyway, so he might as well move. And when he moves, he becomes
A positive 2b squared.
positive 2b squared. See, it was a negative being over there anyway. And then what? Continue.
You get to factor.
We finally get to factor. He's been looking forward to this. What do we do?
You take out the x and it leaves you with a minus b.
Excellent.
And then you got a trinomial over there.
We do. What doeth we with it?
You got to factor it.
Yeah, how?
You put a's. You get a's, yeah. And then you got b's on the other side.
So like backwards FOIL.
Yeah.
Yeah, let's do that. And b's on the other side.
Then you gotta put 2 minus signs.
Good, 2 negatives.
And then you get 2 and 1. And you got it. I think.
Kind of, we're close. We don't have x by itself yet though.
Then you gotta divide by a minus b.
Good, I'm gonna show the canceling, but remember it is being divided, so when we get our answer of
X equals a negative 2b.
we should specify that
A minus b can't equal b.
good, a minus b can't equal 0, so a doesn't equal b. Questions on this? Obviously Michael got to work the problem through. The rest of you right there with us, understanding what we're doing? Anyone want to work one kind of like what Michael did, just to make sure you've got it before you work on your own, or do we feel like we're ready? How many say, I'm ready, I got this? How many say, I'm still a little nervous, can we do one more? All right, why don't you do numbers 1 and 5 on the handout? Number 1 and number 5 on the handout. I'm going to give you a chance to get a head start, and then I'll work them both on the board. Obviously, if you get stuck while you're working, raise your hand, I'll come by and help you. One and 5 from the handout. Success. Anyone need any help before I start putting it on the board? Going once on help? Going twice on help? Let's take a look at number 1. How many got? The x is equal to c squared minus cn plus n squared, or n squared minus cn plus c squared. It's the same thing, where n cannot equal negative c, or c cannot equal negative n. All right, any questions on this one? I felt really good about that answer. I feel a little weird about this one. I'm not sure if I made a mistake. Did anyone else get 8/3 for your answer? All right, so let's see, did I do something wrong? We should have found the least common denominator to be x negative a, x positive a, correct? Okay, so we multiply by an x plus a because the x minus a's cancel. First gives 2x squared. Outer negative ax, inner positive 2ax, combines gives a positive 1ax, and then last is a negative a squared. Then here, we've got to change the signs as we multiply x negative a, x negative a. So x times x is x squared, but it becomes negative. Negative ax is negative 2ax, becomes positive, and then negative a is positive a squared, but it becomes a negative a squared. And then here, it's 1 times the sum and difference, right? So square the first square, let's put a minus sign, times 1 is x squared minus a squared. So we should have had this step correct. How many had that line correct? Okay, only a couple of you. Questions on that? How many was the negative sign that threw you off? Okay, a couple of you. Questions, comments, where were the mistakes then before getting to this point? Feedback?
I got confused while foiling.
Okay, all right. Makes sense now though. I just gotta be careful. Any other questions, feedback? All right, from here, I had a 2x squared and a negative 1x squared gives x squared. But that combined x squared is gonna cancel with this one. So I knocked the x squares out. I also saw that either of the negative a squares could cancel with this negative a squared, so I knocked those out. So I only had an ax and a 2ax, which gives 3ax, negative a squared, brought the a squared over as a positive, divided away 3a, move this out anyway, sorry, divided away 3a, and this a canceled with one of those a, so I have an a left in the top, a 3 in the bottom, and this a that canceled can't equal 0. I think I'm right, I got an answer key to this somewhere. What number was this? Number 5? It is correct, it is a over 3. Okay, all right, I was second guessing myself when nobody else got it. Questions on this? Questions on this? Abby's look says questions.
I got x equals a. Somehow I got a 3 on the other side.
You had a 3 on the other side as well.
Or, I don't know, but I got x equals a.
All right, questions then? You know what, here, if this was a negative 2ax, you might have had a negative ax here. You had a positive 2 and a positive 1, so you got the 3ax? I don't know. Questions, comments, feedback?
For me, I had a negative ax over there.
Right here. Oh, okay, so your outer inner, you had negative 1, positive 2, but instead of subtracting the sign of the greater, you had the negative, which would have given you ax negative a squared. Okay, so foil, a little bit of a foil issue. All right, any other questions, comments, feedback? I think we got time for just one more, so not as far as I was hoping to get, but do number 4 at your seats. Do number 4 at your seats. We'll do one more as we wrap up the hour today. Try to take a shortcut. It didn't work. I thought right here, if I didn't distribute, I'd already have the x factored out, and then there's an x later on, so that messed that plan up. Oh well. All right, we're about out of time. Look up this way. How many saw 2bx squared as the LCD? 2bx squared. And so the 2bx squared cancels, but there's still an x, which I ended up having to distribute a squared x plus b squared x. Here, everything cancels, but there's a negative. So it's a negative a, positive b. And here the x cancels with one of these x's, but it's still a 2bx times b for 2b squared x. I pulled the 2b squared x over as a negative to get a squared x negative b squared x, and I ditched the negative a and positive b to get positive a negative b. Factored out the x, saw that this was a pair of conjugates, or a difference of squares, factored into a sum and, or excuse me, difference of squares factors into conjugates, or sum and difference, trying to use Abby's word. I should just let Abby be the smart one. And I canceled away the a negative b, but said that a couldn't equal b. But that left me with a 1. And I still had to divide away the a plus b, so I end up with x equals 1 over that a plus b, where a cannot equal b. Did anyone else get this answer on this one? Okay, Genesis, good. Brandon as well. Questions from those who did not?
I got a minus b instead of a plus b.
Okay. Did you put the, right here, did you put the a minus b over the a squared minus b squared and cancel to get an a and cancel to get a b?
No.
Okay, I was about to say, because remember, we don't cancel terms, only factors, so that would be sad face. Questions? Yes, Audrey?
I had b negative a.
B negative a? B negative a?
Yeah.
Because I had negative a plus b and I switched.
That's what
You pull this over here to this side, perhaps? Okay, stay with me for just a second. So we had negative a positive b is equal to, and you sent this over as a negative a squared x. You sent this over the negative b squared x to have b squared x negative a squared x.
That's what I did too.
So that gives you a b squared minus a squared, which gives you a b plus a, b minus a, right? Equal to, and I'm going to flip-flop these and say b minus a. That's going to allow the b negative a to cancel. But we still have to divide away the b plus a. So this should have been our answer, which is the same thing as this. And the b cannot equal a is still going to be our qualifying statement, which is essentially the same as that. Does that make sense? What we should have done if we brought it to the other side. Okay, good question. Homework this evening, you're going to do 5 of these. 5 of these on the handout, number 2, number 3, number 8, number 11, and number 12. 2, 3, 8, 11, and 12. Have a wonderful rest of your day, and you are dismissed.